Alright, it is review time. So let's just kind of work through this review together. I am not promising any mistakes. I think I've got them all worked out. If you catch a mistake, send it to me on Twitter and I'll fix it. Probably won't make a new video, but I'll let everybody be aware of my mistake. Alright? So, number one, a car travels with a speed of 6.3 meters per second, and it does it for 8.5 seconds. How far does it go? Well, if we want to find distance, velocity equals distance over time. Multiply both sides by t, and we get distance equals velocity times time. So we do 6.3 times 8.5, and we end up with the lovely number of 53.6 meters. Alright, there we go. Next up, number two. A jet travels at 480 meters per second, so V is equal to 480 meters per second. You will notice there are two questions. Number one, how long does it take it to go 200 meters? So distance A is 200 meters, and we're looking for time A. For B, distance B is 9.4 kilometers. However, the unit for velocity is in meters per second, so you need to get kilometers to meters. So 9.4 kilometers is 9,400 meters, because there are 1,000 meters in 1 kilometer. 9.4 kilometers is 9.4 times 1,000 meters, so the distance for B is 9,400 meters. If you need help remembering how to do conversions, please reference my metric video. It should help you. So let's look at trying to figure out the times for both of these. Well, time is in the formula V is equal to D over T as well. If we solve for time, we multiply T to get it out of the bottom. V times T equals D. So T is equal to D divided by V. So that means that time A is equal to 200 divided by 480, which gives us 0.42 seconds. And time B, that should say B, time B is 9,400 meters divided by 480 meters per second, and that would give us time B equals 19.6 seconds. Okay, there we go. So we got numbers 1 and 2. Number 3, you run 100 meters at 10 meters per second, then walk 100 meters at 1 meters per second. What is your average speed? This is what you most certainly cannot do. You cannot do 10 meters per second plus 1 meter per second equals 11 meters per second. Divide that by 2 and you get 5.5 meters per second. That is no bueno. Don't do that. Alright? That is not how it works. Okay, so how does it work? Well, let me show you. Alright, so first thing we need to do is to there we go. First thing we need to do is we need to remember what average velocity says, okay? Average velocity is the change in distance over the change in time. So if we assume that this person started at 0, 0, then really the change in distance and the change in time are simply the total distance and the total time, okay? So there we go. Total distance, total time, and that's what we're looking for. So what was the total distance? Well, you ran 100 meters and then you walked 100 meters. So the total distance is easy to calculate. It's just 200 meters. So what about the total time? Well, total time is a little different. If you'll remember, we've already solved for what the formula for time is. It's distance over velocity. So I've got two things I have to solve for. I have to solve for first leg and second leg. So on the first leg, my time will be equal to, I traveled 100 meters, and I did it at 10 meters per second, so time is 10 seconds. For the second leg, I did the same 100 meters, but I did it at 1 meter per second, which means my time for that one is 100 seconds. Please remember the formula that we're using is T is equal to D divided by V. D is not much better. Trust me, that's a D. And then I just plug those numbers in that are on the page. Alright, so the first step was 100 meters at 10 meters per second. Second was 100 meters at 1 meter per second. So we know that we traveled a total of 110 seconds. So, coming back over here, back to this one formula right there, 200 divided by 110 gives us a total of 1.82 meters per second, and that would be your average velocity for that stretch. All right, number 4. Number 4. All right, a car travels at 60 miles per hour for 2 hours and then goes 30 miles per hour for another hour. What was the average speed? Well, just like that previous problem, average speed is equal to the distance total divided by the time total. So we could do, we got to find the total time. In this case, is easy to calculate because we go for 2 hours and then for another hour. So 2 plus 1 equals 2 plus 1 equals 3. Okay? And then what we do is we go 120 miles in the first leg, and then we go 30 miles in the second leg. So our total distance is equal to 150 miles. All right. So that means that we have an average speed of 150 divided by 3, and that is 50 miles per hour. Okay? Number 5. Okay, so A, describe the motion of the graph written in words. That would just be, it's in constant motion. Remember, if it's a distance versus time graph, and it's a straight line, it means it's in constant motion. Alright, what is the average speed of the object? Well, change in distance over change in time equals average speed. And this thing started at 0 and ended at 30 meters, so the change in distance is 30 meters. And then it started at 0 time and ended at 6 seconds, so its time was 6 seconds, so it's 5 meters per second. And then lastly, write an equation describing the relationship between position and time. Well, we just figured out that that the slope of that line, right, was also the speed, because remember that the slope on a position versus time graph is equal to the velocity, all right, if it's a straight line. All right, so that means that this is your slope. So if I wanted to write this, I could write it as distance equals 5 meters per second times time. And that will give us that relationship. And the last one I'm going to do for this section, I'm going to make another video for the second half. Number 6, the image of a meter stick in a photo is 5 centimeters long. What is the scale factor? Well, remember, this is like our thing we had on our paper, where if this was a meter on paper, or sorry, in reality, and it's saying that this is 5 centimeters on paper, then what that means is that we have, for every centimeter on paper, we have 0.2 meters in reality. Because 1 meter in reality was equal to 5 centimeters, 1 centimeter on paper equals 0.2 meters in reality. That's your scale factor. That's like if you were looking at a map and it has on there that, you know, this, y'all have all seen this, right? This far is 100 miles, right? It's exactly what we did here, but we're saying that 1 centimeter on the paper is equal to 0.2 meters. So it's the exact same thing you would see on a map, except at the bottom of your page you would write that right there is equal to 0.2 meters. Okay? That's what a scale factor is. Alright, so I'll finish this up in a second one that shall be called Review Part 2.